In this video, I'm demonstrating example microgrid grid tie. So we can open the example microgrid tie from File, Launchpad. Let's go to Tutorial and Examples, Renewables, Microgrid Controller, Grid Tie. We press the launch and we open the project. In this system, we have a grid-tied microgrid with wind generation, solar, battery, fuel cell, generator, and loads. Now we have ETAP microgrid controller that is responsible to control active and reactive power, as well as performing all the functions that's required for microgrid application, including reconnection, black starts, islanding control, forecasting, and all sorts of functions that's required as part of a microgrid control application. The first case that I would like to demonstrate, we go to the scenario wizard, we bring the rule base. In this scenario, what we are doing, we are simulating a 24 hours of a microgrid, and the requirement is that the microgrid should not export active power to the grid. So it should behave like a load from the grid perspective. Once analysis is done, let's go plot the rule base. We go to the AC cable and let's plot the total active power of various elements of the system. Let's first look at the tie cable to the grid. As you see, we are only importing power from the grid. So no export to the grid, there is no negative power. And also we are limiting the active power import to 2.4. That was part of the requirements of the microgrid controller active power control. As you see here, we have the max import power of 60% that corresponds to that 2.4 megawatt for this microgrid. How this is done, the microgrid controller has sent a command to the battery to charge at the times that there is an excess of generations and discharge to do the peak shaving. Now let's run the other example optimal dispatch. In this example, before running, let's look at the microgrid controller settings. In this case, rather than using a mean emission for active power, we are using the optimal dispatch. Means that the microgrid controller is going to utilize the time of use and restrictions at the point of interconnection defined in the grid tie settings to optimal the microgrid operations and minimize the cost of importing power to the microgrid. Let's run this case. Let's look at the response of the system when microgrid controller is using optimization instead of the rule base for active power control. I am going to remove the battery load and just maintain the tie cable. As you see, we are not exporting any power to the grid. We are limiting the import power to around 2.4 megawatt. But what is different here is that the microgrid is importing less power from the grid, and this is happening because we are using the battery more. So we are charging before 4 o'clock when the electricity is cheaper, and we are discharging after 4 o'clock to do some peak shaving. And this results in more peak shaving and would be more cost effective for this microgrid compared to using rule base. The next scenario that I would like to demonstrate is island and reconnection. In this scenario, we are demonstrating the transition to the islanded mode when there's an interruption in the grid side, and then once the grid is back, we show that how the microgrid controller is going to reconnect back to the system. As you see, at time 10.95, the grid gets disconnected, and then microgrid breaker at the point of interconnection gets disconnected and isolates the microgrid. And at this point, the microgrid controller has already done the analysis beforehand and is gonna shed some loads. It switches the battery to grid forming to make sure that the system can transition to the islanded mode. And then it tries to bring in the generator and then the fuel cell to the system. As you see that the fuel cell and generator is back. One load is back as well, is restored, and then the second load is back. So all the loads are back to the system. System runs in the islanded mode. And then once the grid comes back, the microgrid controller is going to evaluate the healthiness of the grid and the voltage level, and is going to synchronize and reconnect the microgrid back and connect it to the system. We can go ahead and fully simulate the islanding and reconnection to the grid with the ETAP transient stability and ETAP microgrid controller. Let me just plot the bus voltage and frequency. As you see, you can also plot the bus frequency and the voltage during all this transition to go to the islanded mode and then reconnection back to the system and evaluate the performance of each and every assets of the system. The next scenario that I would like to demonstrate is the black start. In this scenario, we are demonstrating that how the microgrid goes to completely black, and then how the microgrid controller is going to restore the assets, the sources, and the loads and make the system energized and operate in the islanded mode. In this scenario, as you see, first we lose the grid, and then the microgrid is going to go almost to the collapse situation. All the voltages goes to zero, frequency goes to zero, the assets all trip. And then microgrid controller detects that the system is black, is going to make sure that all the loads are disconnected, all the assets are de-energized, and then the black start starts. And in this scenario, what the microgrid controller is going to do is going to energize the battery. As it energizes the battery, it's going to brings all the assets and the loads in a proper order to make sure that the voltage and frequencies are within acceptable range. It brings all the loads one at a time, and then renewables one at a time, and it energizes the system, and system becomes energized. Again, you can go ahead and plot the voltage and frequency during the black start and make sure that the system performs well during the black start condition. You see that the system goes to the black, voltage and frequency collapse to zero, and then microgrid controller restores the system and brings load and generation one at a time to make sure that the voltage and frequency are maintained at proper level. If you're interested to learn more about ETAP microgrid controller, please visit us at etap.com and look at the microgrid controller product page. In this page, you will find lots of information about ETAP microgrid controller and all its features and benefits to control and manage your system. And there are lots of videos also available and recordings and details about the ETAP microgrid controller solution.